So let's start with class example number 4. Use trig ratios to determine the lengths of AB and AC in the following given triangle. Answer to the nearest foot. So this is my given angle. This is my adjacent side. So I have my opposite and my hypotenuse sides to find. So pick a side to find. It doesn't matter which side you pick. I could pick the hypotenuse to find first if I wanted to. So hypotenuse would be adjacent and hypotenuse, which would be cos. So I get cos of a 74-degree angle equals 109 over the hypotenuse, which we can just call h. I have to get the h from being a dividing to a multiplying, so I multiply both sides by h. And then divide. So really what ends up happening is the h and the cos 74 trade places. And what is the length of the hypotenuse?
395.
Thank you. Now to find out the opposite side, I could do one of two calculations. I could use Pythagoras' theorem because I now have two side lengths, or I could use another trig function. If you're going to use Pythagoras' theorem, if you rounded this number, make sure you don't round it in your calculation for Pythagoras, because it could cause you to be off by 1/10 of a degree or a whole number, and then you'll get it wrong. So if we stick to our trig functions, I have opposite and adjacent, that's tan. So tan 74 becomes the opposite side, which we'll call O, or maybe we should put OPP so I don't get it confused with 0, over 109. So to get that opposite side by itself, I'm going to multiply by 109. And what do I get for this opposite side? How many feet? 3 feet? 380? Yes or no? Okay, so let's look at question number 5. A large tree is to be transported to a new location, and the tree will be held vertical by the means of 2 guy wires of unequal length on opposite sides of the tree. One of the wires makes an angle of 48 degrees with the ground. The other is 12 meters long and makes an angle of 56 degrees with the ground. Both wires are attached 3 meters down from the top of the tree. So if I create this vertical line on my tree, and then I attach my guy wires, so if this is my 56 degree, my 48 is going to be, so this one would be my 56, this one would be my 48, this measurement right there is 3, and the one that makes a 56-degree angle is 12 meters long. So the question is, determine the height of the tree. Well, I have an angle, the hypotenuse, and I need the opposite side. So that's going to be sine. That'll help me find the height of this tree. So sine 56 will equal x over 12. To get x by itself, I multiply both sides by 12. And what is 12 times sine 56? What did you get here? Is that the height of the tree? Yes or no? No, it's not. This is 9.9. What do I need to put in?
Add 3.
I need to add in that 3. So the tree is 12.9 meters tall because I have to add in that 3. Part C says determine the length of the other guy wire. So that's this one. We're going to call it Y. Now that I know what X is, I can use X in my calculation. I have the sine of, or opposite side and hypotenuse, which would be sine. So my sine of my 48-degree angle equals X over Y. When I go to put in my X, I don't want to just leave it as 9.9 because that's a rounded answer. I want to have more decimal places. Or if I can, I want to try to keep this measurement accurate. So if I type in what this one was, which was 12 sine 56, there's by 9.9485, etc. So that's what I would put in here. 9.9485, etc., etc. And remember what I said before? When I'm dividing by y, I can simply change these two around. So I can rewrite this as y equals that value I calculated before divided by sine 48.
Yeah, you just subtract it.
Which equals what? Wait, 3 what? What's after the 3? So to the nearest tenth, that would be 13.4. And then part D says calculate the distance between the two guy wires, so the horizontal distance. So I could call this A and this B. So to calculate A, how did you calculate A?
No, I know, but I'm just
I have an adjacent and a hypotenuse, so I can use cos. Cos 56, adjacent over hypotenuse. So to get A by itself, I multiply both sides by 12. And I get that A is 6.710 if I leave that to 3 decimal places. When I look at B, I either need X or I need Y. It doesn't matter which one I pick, as long as I pick one of them. And then I have to figure out what my trig function is going to be. So let's say I decided to pick Y, because Y is probably still in my calculator from before, or it might still be in my calculator from before. So cos 48 would equal B over that Y value, which was 13.38, etc., etc. So again, I would cross multiply and I would get that 13.38 times cos 48. And what is the length of B? What did you get, Courtney? What if you were to use your calculator to figure that out right now?
I'm just leaving. You like cross multiply, so you go sine 46 times 440, and then you go p times sine 59, and then you divide by sine 59. On both.
Okay. If I had kept this a little bit more, like not rounded, I get 8.958. So then the total distance, or the horizontal distance, would be the sum of these two numbers. And then rounding my answer to the nearest tenth. And I would get 15.7 meters. So question E says the guy wire in C, so that's this wire right here, breaks. So what I do is I take this guy wire and I attach it. I don't change the length of it, but I attach it so it's now 2 meters from the top of the tree. So if I draw a sketch of what that would look like, here's my tree. There's the ground. And then here's my guy wire. So that's a sketch of the situation. The guy wire is 13.4. And the height of the tree, remember my tree was 12.9 meters? If I take it 2 meters down, the height of my tree, or this height here, is going to be 10.9. And now I'm asked to calculate this angle measurement. We'll call it x. So what I have is I have an opposite side and its hypotenuse. Which trig function is opposite and hypotenuse? Sine. So I get sine x equals 10.9 divided by 13.4. To get the angle x, I have to do that sine inverse. And how many degrees do I get? So to the nearest degree, 54 degrees. So your questions